Let's prove some trigonometric identities. So proving trig identities. Let's use some different style identities. One of them that I want to do is this. So I'm just going to start with examples and try to walk you through this. I've got the tangent of theta times the cosine squared of theta is equal to 2 times the tangent of theta cosine squared of theta minus the tangent of theta all over 1 minus the tangent squared of theta. Now this one is not necessarily super easy or super hard. Let's just check it out though. Step 1, I need to look and see which side I think is more complicated. Well, I really think that one looks a whole lot more complicated, so that's the side I work on. The second thing I want to do is I want to make sure that I save what I can from this so that it looks like this. I need a tangent. Well, this has a tangent in both parts of the numerator, so I'm going to pull that out in factoring. I need a cosine squared. That's fine. I've got a cosine squared here, but I don't really have one here, so I'm not going to worry about that one right now. And then I've got to do something to get rid of 1 minus tangent squared, because this one doesn't have any denominator written. It's got a 1. So first thing I'm going to do is just pull this tangent out. So I've got tangent of theta. If I factor that out, I've got 2 times the cosine squared of theta minus tangent out of that leaves me with 1. 2 times the cosine squared of theta minus 1. So I've got that, and then it's divided by 1 minus the tangent squared of theta. Well, what I need to do is I need to work on this part of this because it has to turn into cosine squared. And I don't see how it's going to do that yet, so we're going to work on it. I'm going to turn these into sines and cosines. So I'm going to keep the tangent, not change it. And then here I'm going to write this in sines and cosines. Well, it already is. 2 cosine squared of theta minus 1. This is 1 minus the sine squared of theta over the cosine squared of theta. Okay, so what I need to deal with now is maybe multiplying so that I don't have 3 levels of fraction. The denominator that's giving me 3 levels is, or a complex fraction, is cosine squared. So I'm going to multiply here by cosine squared of theta, and I'm going to multiply here by cosine squared of theta. So here's what I get. I've got the tangent of theta. Now, notice this. I need cosine squared of theta, so I'm going to put this right here, cosine squared of theta, and I'm not going to do anything with it. I'm going to leave this as 2 cosine squared of theta minus 1. Okay. This I'm going to have as cosine times 1, or cosine squared times 1, so that's cosine squared of theta. And then here, cosine squared of theta times sine squared of theta over cosine squared of theta with a minus. So this is minus sine squared of theta. I am going to guard these and try to make this equal to 1. Now you might recognize that it already is, but we'll push it so that it becomes 1. So we've got tangent of theta, cosine squared of theta. Now what's this part? Okay, I want to break this up. I'm going to call it cosine squared of theta plus cosine squared of theta minus 1. This is cosine squared of theta minus sine squared of theta. Now, sine squared of theta plus cosine squared of theta equals 1. We have that down. Sine squared of theta plus cosine squared of theta equals 1. Okay, over here in our thought process. So what is cosine squared of theta minus 1? Well, look at this. if I subtract 1 from both sides and subtract the sine squared of theta, I can say that this is cosine squared of theta. And then this is, I've got to make minus 1. Cosine squared of theta minus 1. And then I push this over to this side, I get minus sine squared of theta. There's a little algebra there, but cosine squared of theta minus 1 equals minus sine squared of theta. So this is equal to tangent of theta, cosine squared of theta, and then here I've got cosine squared of theta. And then this thing I just worked on, cosine squared of theta minus 1 is equal to minus sine squared of theta. Here's cosine squared of theta minus sine squared of theta. These guys are identical, so that cancels and becomes 1. So we've got it now equal to the tangent of theta, cosine squared of theta. And so we're done. You always work on one side and one side only when you're proving an identity. Let's try another one. The next one that we have is this. It has the sine cubed of theta is equal to the sine of theta minus the cosine squared of theta times the sine of theta. Now I don't have any cubes in there. I do here. So which side is more complicated? That's a good question. It really doesn't matter, but I'm going to choose this side to be the more complicated side. So I'm going to try to start making it look like this as much as possible. To do that, I'm going to save this sign that's in both of them. So I'm going to use factoring and take the sine of theta out. If I take the sine of theta out of the sine of theta, I've got 1. If I take the sine of theta out of here, I've got minus cosine squared of theta. Well, sine squared of theta plus cosine squared of theta equals 1. So 1 minus cosine squared is equal to sine squared. So this is sine of theta multiplied by sine squared of theta. Aha! We've got sine cubed of theta, and we're done. So that one's not too tough. Another example. This one has the sine of 2 theta divided by the sine of theta, and it's equal to 2 over the secant of theta. Now, I think this side's more complicated because it's got a double angle and a single angle. That's what makes it more complicated. So I'm going to work this side, leave this side alone. My goal is to make this side look like this side. Now, something I might go off and think about is the fact that secant is 1 over cosine. So this thing right here, you know, when I'm thinking about it, it's 2 over 1 over cosine theta, which is 2 cosine of theta. So if I get 2 cosine of theta, I can kind of push it to make it look like this. I am not going to make anything that's false, but I know what it's equal to. So I'm going to keep that in mind. Okay, so sine of 2 theta. What is the formula for that, or the identity? It is 2 times the sine of theta times the cosine of theta. It's over the sine of theta. This is all multiplication, so I can cancel this. I get this is 2 times the cosine of theta. Oh, guess what? It's what I was thinking about. So this is 2 times 1 over the cosine of theta, which is 2 over the secant of theta. And I literally have to make it look like the other side. So there it goes. So that was not too bad after all. Here is another example. We've got the tangent of theta times the sine of 2 theta, using sine of 2 theta again. And this one's equal to 2 minus 2 times the cosine squared of theta. Now let me take this side because it's got a double angle and a single angle. That's what makes it more challenging. So I'm going to turn this into single angle. I know that the sine of 2 theta is 2 sine theta cosine theta. I used that last time. So I've got tangent of theta. I don't need to keep that because this doesn't have it in there, but I've got that. And this is 2 times the sine of theta times the cosine of theta. Okay? Well, let's turn this into sines and cosines because this has cosines. So this is the sine of theta over the cosine of theta. That's what tangent is equal to. This is multiplied by 2 times the sine of theta times the cosine of theta. Well, I've got all kinds of multiplication here, and notice cosine is the same numerator and denominator. So now I have this. I've got 2 times the sine squared of theta. Well, guess what? We're back to sine squared plus cosine squared equals 1. What's sine squared equal to? Sine squared is equal to 1 minus cosine squared. So I take that out of context a little bit. 2 times 1 minus cosine squared of theta. Now, what I was trying to do is make it have cosines. So I did. Look at this. Now all I have to do is multiply. 2 times 1 is 2 minus 2 cosine squared of theta. So there are some examples. Not all the examples in the world, but there are some of them. Okay? I've got one more that we can try to deal with, and let's not.